Good afternoon. Can I just quickly ask a question? Who understands English well? Okay, so half of you. Okay. I will try to go slowly to help translation and for those who do understand English. Good afternoon. My name is Marek Suchocki. I work for Autodesk. I'm based in the United Kingdom and I cover the EMEA region in the focus of civil infrastructure. So I'll first explain a little bit about me so you know why I've been invited to present to this Transport Congress. So as I say, my name is Marek Suchocki. I am covering the EMEA region focused on civil infrastructure, and I cover the entire life cycle. So from concept and planning through construction into operation and maintenance. And I deal primarily with clients. So I try to talk to rail operators, road operators, utility companies, and their project teams. I am a civil engineer. I'm a chartered civil engineer. I'm a fellow of the Institution of Civil Engineers. I'm also a fellow of the British Computer Society. I'm a member of the Geospatial Practices Committee for the Institution of Civil Engineering Surveyors, and I'm on the Information Systems panel at the Institution of Civil Engineers. I'm also the chairman of a industry academia group called Construct IT. I'm on the UK Building Smart and UK and Ireland Building Smart chapter. I'm also a member of the British Standards Technical Committee that has written much of the BIM guidance for the UK BIM mandate. And I'm on a number of the subgroups working for the UK government BIM mandate. So BIM Technologies Alliance, which is all the vendors, and I'm also on the management board of BIM for Infrastructure UK. So the strategic group looking at how infrastructure adopts BIM in the UK. So that's all you need to know about me. My presentation, I'm going to commence with a small business case. Why do we need BIM? Because you're here for a conference, BIM may be expensive, BIM may be difficult, so why do I need to do this? So the first thing is, there are many reports suggesting that globally we must have a massive investment in infrastructure. I know here in Russia you will be building some 4,000 kilometers of new road over the next few years, and you've got rail to do. In China, they're doing 30,000 kilometers of new railway line, the same in the Middle East. So there's huge investment in infrastructure, and it's got to grow by 50% by 2030. And that's suggested that is 53 trillion US dollars of investment. Now, if you're in civil engineering in this room, this is great news. We've got work to do, but we have some problems. One of the big ones is we cannot get people into our industry. There was a report from the Association of General Contractors in America. They said that 83% cannot get workers, 60% cannot get professional engineers and project managers. In the UK, a report from the Royal Academy of Engineering said that we need 100,000 science, engineering and technology graduates every year. And yet we only create 90,000. And many of them go into other industries like finance because it's more interesting or they get more money. So we have not got enough people to do the work today, let alone deliver all of this extra infrastructure investment. On top of this, unfortunately, construction is not a very successful sector. We have always had project problems in every country around the world. These are just some examples of failures on projects. Vancouver Olympics, 8 years ago or so, they had massive cost overruns. In Scotland, they built a new government building, Parliament, hugely overpriced. The bottom corner is Berlin Airport has 66,500 problems. That was 5 years ago. It still isn't finished. This is a project that is 5 years late in Germany, the efficient, fantastically always successful country. This one I always laugh at the bottom left. I don't know if anybody reads French or knows French. Train trop large à la SNCF. Quelques centimètres qui vont coûter des millions. trains too large for SNCF. A few centimetres is going to cost millions. SNCF 2 years ago had new trains delivered which didn't fit on the platforms because they hadn't talked to the operators of the platforms well, and so they have to now spend millions to fix all those platforms that were too narrow to get these brand new expensive trains through. So poor interoperability, poor coordination. These are issues that we suffer from in our industry. So how can we, so these are reports that we knew about from the UK and America. This report here, placing and management of contracts for building and civil engineering work, that is a 50-year-old report. 1964 it was written, and it talked about improving communication, improving planning, improving coordination. Why is it 50 years we've said the same things and we don't change? This report, the NIST report in America, 10 years ago said that there are $15 billion of inefficiency through poor interoperability, of which 2/3 the client pays for. This final report on the right, Never Waste a Good Crisis, came out in 2010, and it said we are in a financial crisis. Can we change now? Because we haven't changed for the last 40, 50 years. And that drove the UK to do its UK BIM mandate, because we said one of the things that came up for actually over 10 years that we knew that we could do was use technology to improve our construction processes. So that's the kind of, why do we need to do BIM? And this was just research from roughly 80 different resources that shows that there is no question BIM is helpful. BIM provides benefits over traditional 2D, typically in cost, planning, predictability, operation and maintenance, things that companies can expect: improved win rate, better reputation, higher quality, more money, more profit, attract the right new people. And the things that you can do less of are make errors, have changes on projects, have delays on projects, make people work long hours because they're having to catch up constantly. Safety is improved. And actually, you can reduce the thing called contingency, which is that money that you go, I'm not sure. So you reduce, you're more accurate in it's more predictable. You are more accurate in your submissions to your customers and also in your planning of work. And all of these things can contribute to what we call rework. And these other items contribute to waste and loss of respect. So if you don't do BIM, you're constantly at risk of losing your customers. If you do BIM, you get more people to join your companies and you can actually win more projects. So those are the things that you will do. If you do BIM well, this is not a question. This will happen. And actually, all of this has led to many nations around the world starting to create firm national mandates, departmental mandates, project mandates for BIM, and they're growing everywhere around the world. The way this is kind of building is basically red is a solid requirement in some government, blue is a project or a departmental mandate occurring, and the green is ones that are being developed at the moment. So everywhere around the world we're seeing BIM becoming a real requirement from governments, from national departments, from clients, and from project teams. So let's get some detail on some of that. So who's heard of Building Smart? Okay, a few of you. So Building Smart is an international organization that is split into chapters, so different countries have their own specialist groups, and they are focused on developing open international standards for construction, mainly for BIM. And because my presentation is around infrastructure, this is an explanation of what is happening around infrastructure. Infrastructure is been slow. It's been focused to date mainly on buildings. But a year ago, IFC Alignment 1.0 was published. This is a standard way of sharing the information of a center line, of a road, of a railway line, of a pipeline. And the idea is that you can use this same definition in a product like a civil design tool as well as a building design tool, which helps you coordinate structures with the civil structures. So that's the intention of IFC Alignment. So this is the first one that has been published. And And there is an overall architecture that has been prepared by Building Smart. This has been supported by many national clients, such as the transport agencies in Sweden, Holland, the UK, Korea. And the other things that are going to be developed out of it is that IFC alignment is being extended to include things just off the side of the single center line, which will be IFC alignment 1.1. And then there are other developments such as IFC bridge, IFC road, and IFC rail. IFC road has already been developed by Korea, but they're going to now enhance that to include the IFC alignment as the base reference line. China has developed IFC rail, and again, they need to include the IFC alignment. So when you design a road, the core is the alignment, and then the additional part is the road or the rail or the bridge, so that the bridge sits on the alignment. I'll explain a little bit more why this is valuable later. So that's an international group. Let's look at a couple of countries. So in Holland, Rijkswaterstaat, that is the National Roads Agency, they have been running a program for the last 5 years to have the projects deliver better information back to the client. And they have adopted a standard called COINS. And COINS is basically a set of documents and data. Actually comes in a zip file, and it includes a database of structured information, so the detail on the assets, GIS, so the large-scale information. It has documents, drawings, PDF documents sometimes, maybe spreadsheets, and it has 3D models. It effectively comes as a zip message, which includes, I don't know if everyone can see this, but the COINS container is, you've got BIM data, you've got structured XML data, and then you might have, here we've got Revit, IFC, DWG, Navisworks. So it will include the documents, but effectively when the client receives a pack of data, it has everything they want. And the COINS schema describes what needs to be in that. Now, they have now done a number of projects on this, but here's an example of the data that could be found on an object. So they're now able to integrate the database and link it to the model data and the geospatial data. So they really are now receiving rich information about their projects. And that can include structured data as well as the geospatial and the civil information. And here are some examples of the projects that they've already delivered which have submitted COINS information back to the client. So this is something that really is happening. And what's great is that the supply chain is learning how to deliver projects in BIM, how to create a COINS data package, and the client receives this better information to introduce into their asset management systems. So they are on a very good learning program in Holland on this. We look at Finland. So Finland was the first country in the world to have a national BIM standard. These came out, I think, in 2009, so they've had them for a long time. And from April 2014, they required the transport sector to deliver in a format called Land XML Infra Model 3. Land XML is a standard for exchanging essentially transport data. It can link to geospatial and civil engineering tools. Infra Model 3 just includes additional data parameters that the Finnish road agency wanted. In Germany, they've recognized their inefficiencies in construction, so they've set up a national reform commission for delivering BIM. They've actually got, this year, official statement of BIM in their public procurement, so now specifying BIM as a requirement. And they have a BIM working group called Plan and Baum 4, and they are going a phased rollout of BIM across the whole country. And Autodesk is the first private sector company to get involved in Plan and Baum. So as a company, we've committed to helping the German BIM initiative to be correctly developed. And the good thing is that the Germans are not trying to do everything, they're doing it in a phased rollout. They're learning as they go, focusing on the priority aspects first. Just some examples from America. America does a lot of BIM, so they've been doing BIM for many, many years. This was a project which I thought I would share, which is from the US Army Corps of Engineers, so part of their military team. They have a huge number of assets around the United States and internationally. And the National Building Council, NIBS as it's called, And they did a project called Civil Information Modeling with industry. And they looked at the data we use in civil engineering, civil data, geospatial data, survey data, data for subsurface utilities, pipeworks, electrical cabling. And they came up with the idea of BIM for civil works, which is a civil information modeling. And they looked at saying that typically GIS covers a number of areas going from the world down to sort of a land parcel. When we look at BIM, we tend to talk about things like structures, bridges, buildings, physical assets. And they said that there's a piece in the middle that is poorly handled, which is the more detail around the project area for civil engineering projects, which is where they're focusing this civil information modeling on. And so this study looked at that. And so this is the kind of way of saying that GIS covers the whole area, BIM is the building, but SIM is the project. So that was their kind of idea of saying, well, let's focus on the specific information that we might need there and how might we create it, how might we develop it. That's what that project was about. This was a report that just came out this year from the US airports. It's an airports report. It had many, many airport clients involved as well as supply chain. And they looked at how are airports in America adopting BIM. In truth, they are doing very well. They've got a lot of projects in BIM, but the client isn't entirely in control. It is mainly being done by the supply chain, the designers and the constructors. And they found there's some lessons in terms of the clients don't really have much guidance on how should they do BIM and how should they do BIM into facilities management. They don't really know what is good BIM and what is bad BIM. So they need to develop some key performance indicators to show performance. They need to understand how to deliver a return on investment. You know, how do I know that the BIM has given me a payback? Whether it's on the project or it's in operation. They need to learn about this. So they've kind of identified the problems. And the final one, and I think this is a big problem everywhere in the world at the moment, is including BIM specification in contracts is a struggle because most contracts are very traditional, they're kind of CAD-based, that they're very restrictive, and actually with BIM we share models, we hand over intellectual rights, and this is not clear in current contracts. So they know that that's a gap. Here in Russia, already since December 2014, you've had a instruction for adoption of BIM in the construction industry, and I'm sure that's part of the reason you are here. So this is extremely positive, and you're obviously aware that we've had some BIM standards that Autodesk helped support in the development of. So you've got some guidance on how to do BIM on the project, and this is a great starting point to learn about the beginnings of what should I do if I'm a building designer, and what should I do if I'm a civil engineering designer in my project. So you've got some excellent starting position for learning about BIM on your project. So I'm going to spend a little bit more time now just talking about the United Kingdom, where I'm from, and our Level 2 program. So from April this year, every public, centrally funded public project has to do BIM. There's no question they must include BIM in their specification. And we are trying to achieve a thing called Level 2, which is on this graph, the red line. Level 2 is just a set of procedures and technical requirements that need to be included in the execution and delivery of a project. This is very complicated. So what we've done is we've tried to help industry by developing a number of guides or standards for how you will do work. We focused firstly on collaborative working. How do I share information with my colleagues on a project? How do I deliver a project in BIM? What should I do with BIM data in operation? What data format can I help to share my information with the customer? How do I specify a project? I'm a client, I have no idea, I have no understanding of BIM. So tools to help the client specify. What are the contractual changes, the commercial amendments to contracts I need to make? How do I classify things? Can we name assets consistently in our projects? This is a massive problem. Some people call things in the UK, I'm going to use English language, some people say it's an elevator, some say it's a lift, some call it a vertical transportation system. Are we talking about the same thing? Who knows? So classification, data security. Obviously, we live in difficult times. Can I make sure that the right people are seeing my data? because much of our construction sector, we are creating critical assets for the public, make sure that the data about those assets is properly secured. How do I prepare the client, the whole organization, to adopt BIM? How do I include operational information and requirements in specifying projects? How do I train the academic sector? How do we get the right requirements in education? And finally, what are our plans? Where do we want to take this? Once we've got this working, we want to go a bit further. So we've got lots of guides. And part of the problem is that this looks extremely difficult, extremely complicated, and it's probably better that I don't do this because it's just too hard. I'd rather carry on the way I used to. This is how many people look at BIM, is it's just too difficult. Actually, most of these guides are not, you only need to read a few of the guides if you're in our supply chain. If you're a client, you might want to read stakeholder guidance and specification. If you're a designer, you may only want to look at the capital project BIM stuff. So this is just we've covered the whole market. If anybody's at all interested, all of this is available at that link, bimlevel2.org. So if you have any aspiration to read about what we're doing in the UK, feel free to please download all of this information there. It's publicly available, and we're very happy for other countries and projects to adopt this. This is just a little bit more detail about our capital project delivery process. So this is I'm going to stand here. So this is a project starting from briefing through design, construction, into handover and operation. And we talk about the idea of data exchanges or data drops, where the project must give the customer some data so the customer can check, are we doing what is required? And these are these data drops. How does this all work? Well, actually, it all starts in the top corner here, which is a thing called the employer's information requirement. Now, this is where the customer says, this is the data I need at these points in time, so I can be happy that the project is going to plan, and this is the data I need here at the end, so that I can run my new asset correctly. Now, this is a massive problem for clients. Most clients buy something cheap. Now we're saying, buy something to meet your requirements. So you need to know what your requirements are. So this is actually a big, big area. So if you're a customer, if you're a client, to do BIM, don't complain if your project didn't do what you wanted, if you didn't ask for what you needed at the beginning. Okay, so the client says what they want. The supply chain then delivers a BIM execution plan that says, this is how I will deliver your information. And the successful bidder, who's best BEP, has to then create a master information delivery plan. The big detail on exactly who will do what at what phase. And once you've got these plans in place, you've done a lot of planning, what tools you're going to use, who's going to do it, to what level of information, you can then go ahead and deliver your project. And in the UK, we have suggested that we will exchange the data, not models, but the data using a format called COBie, which can be delivered as an Excel file or as a database. So this is quite hard, but we are learning our process at the moment on how to achieve this. But particularly the BEP, MIDIP, and the EIR are a real big focus. Ask for what you want, say how you're going to deliver it, and then show the full detail on it, and then go ahead and do this. And I'll come back to this later very briefly. Oh, sorry, I just want to say one more thing. This standard, PAS 1192 Part 2, is our BIM for projects, and it is being developed into an ISO, an international standard, ISO 19650, and that is due for publication in just over a year's time. So the UK approach is being adopted as a good role model example for the international community. So this will be the basic framework for future BIM on international projects. We've got a lot of clients that are asking for this. This was some examples done from the Environment Agency, people who look after our river and coastal defenses. And they've said that we're going to create asset information requirements. The supply chain will then do some modeling using tools like Civil 3D and Revit, aggregate them in Navisworks, and then we want to get that COBie out from Navisworks. So this is what they wanted to do, and we'll show you later how this is being done. This is High Speed 2, the biggest project in Europe. They've said from the outset, this is a massive project going from London to Birmingham. Huge amount of money. These are all in billions of pounds against the design, tunnelling, surface. So there's lots of spend. It was set at 20 billion. It's now almost 50 billion because they're going to extend it further to the north of the UK. And they've said that BIM is our lifeblood. It's our central nervous system. This project will not be delivered without BIM. And they've come up with this whole BIM framework and model. And I'll just explain a couple of things on this picture. So this is, how are we going to do it? We're going to use collaboration. We're going to get it right first time. And up there, I don't know if anyone can read it, but it says 150 years. They know that the railway line is going to last 150 years. In the UK, and I'm sure here in Russia, you have railway lines that are over 150 years old. When we build infrastructure assets, they're not for 10 years, for 20 years, they last centuries. And they've got a little picture here of the devil. And the devil is saying, come back to doing it the old way. And this is the trough of despair with risk, which is, this is where we are today. They don't want to do it like that way. So they've said that BIM is a way of setting excellence in their project preparation, design, construction. And they've even said they want to build HS2 3 times. They want to design it in BIM. They want to construct it in BIM. They even want to simulate it and run it in BIM before they actually build anything. So they want to use BIM to fully iron out any problems before they actually break ground. So let's move forward. So how are we Autodesk helping? Well, a lot of what you've seen and a lot I talked about involves some technical stuff. There are things you have to do, which isn't just modeling. It's actually creating and transferring data. So firstly, civil engineering has always been very hard to add additional attributes, the extra information around the model objects. So we've actually done a huge investment, which I'm pleased to say I was very much at the heart of developing to add extended property data to civil 3D objects. So effectively, you can have definition of property sets. You can create your own property sets. They can be Russian property sets, they can be client property sets, they can be whatever you want property sets. But essentially, for a model object, you can say, I can add extra information. It's not just what came out of the box, I can add extra stuff. And this will become clear later. And we're doing some further developments around corridor development, and all of this is actually trying to pass the data through the process. So it's less about the modeling in the civil engineering than it is to get more data to flow through the different stages of a project. We can apply classification. I mentioned how you name things, the description of the objects. Well, of course you can apply classification to civil objects. Main one is Revit. So in Revit, we can set up a classification system. In the UK, we use a thing called Uniclass. You identify the thing that needs to have some classification. You then select the appropriate classification for it, and you apply it and use it somewhere else. So effectively, you pick on an object, you say, add some classification, add the classification, and then that is now on the object. You can do the same thing in Civil 3D, using these extended property data sets. So first, you have to do a model, and you extract it as solids. And then on that solid object, you add a property set. So you actually create the property that you want. And then you add the classification as a property. And then, again, that data is now available later in the process. You can get COBie. So COBie may not be relevant to you at the moment. Don't worry about it. I'm going to go through this quickly. COBie is a standard structured data set from Revit. We can do it because we have an extension for Revit. So you set up your basic COBie data, you assign fields, you make any changes you want, so you don't have to send all of the objects out. You just say, I only need to extract the information that my client has asked for in their information requirement. And then you have the COBie Excel file. So we are automating the generation of a standard structured data set. We've got a Navisworks extension for COBie. Now, this becomes quite interesting. You know, if we've got it straight out of Revit, why do I need it from Navisworks? Well, because Revit is one product. I may have model objects from not just Revit, but from Civil 3D, from third-party products. So by doing it in Navisworks, we can do exactly the same thing. We set up our, this field maps to that field in COBie. We then pick the template COBie that we want to use, so we fill it into this one. We import the model data, and then we export the file. So we're absolutely simplifying the process of generating a structured data set. Now, this doesn't matter that it's COBie. This is information that a client may want, and they can use that into asset management systems. So they now have data. It's not about geometry. This has got nothing to do with the model. This is, I have these assets, and I know what they are. And actually, most of the data gets filled in the spreadsheet by the manufacturer, the details. The constructor fills that in. We can even test models. So we have a model test. If you have a set of rules, so standards that you want to obey, we have a model checker that's available. So you select the model checker, you configure it to follow the rules that you're after. You run your checks on the model quality, and then you finally run a report saying what parts of the model meet the requirements that were set. And again, from the UK process, some of this would be defined in the employer's information requirement. So this is a technical way of meeting something that was described at the beginning of a project. Now, interoperability, I mentioned that American report that said about $15 billion of lost productivity due to poor interoperability. I will argue that today we have less problems with sharing information between technologies, using those building smart standards of IFC. As a company, we are massively supportive of this. We support it in around 17 different products, both in building design, civil design, and even in tools like Autodesk Inventor from the manufacturing side. So we're very happy to share and use IFC data. It's an open standard. It's not an Autodesk standard. We're happy to use it. It's not perfect because it doesn't work in every situation, but we're happy to support it, and we will happily support future developments of IFC. Oh, sorry. If you're at all interested, you can get this at autodesk.com/IFC. So that's another link for you to copy. If you are working on projects in Russia or internationally that require IFC, please do download our plugins. They're all freely available. There's no extra cost to them. I mentioned LandXML from Finland. So we funded a development into Civil 3D for LandXML Inframodel Free. It's an add-on that gives you some additional functions. You can import a LandXML file. It gives you some warnings if things have not fully transferred, but this is a full import of a LandXML Inframodel Free file. And I actually exported it and then re-imported it, and you see it was the same data. So it can allow for round tripping, even though that's not a main intention, but the thing is working. So we're already supporting a different standard that was a client requirement. We've also been asked to support IFC alignment, which I spoke about earlier at the around the infrastructure standard for IFC. And the first place is you need to have it out of civil model. So I've got a road design or a rail design. Can I create the alignment to take that out so I can use it somewhere else? So first request, IFC alignment. Why do I need that? Well, perhaps so I can bring it into Revit. So that alignment now helps me coordinate, for example, a bridge deck. So that bridge is now set in the correct position. I'm not having to guess. The alignment matches. So this is all about coordination of different stages in the process. Talk about doing it for InfraWorks. Now this is where it gets very interesting, because if your customer says, this is the alignment we want to follow, but all they've been able to do is draw a single line. They haven't got the technical ability to do all the detail. You can take that alignment straight into InfraWorks and immediately create a road or a rail or a pipeline, because it will just translate it into a full object. Now you can do some optimization on it, and potentially, as soon as you've brought it into InfraWorks, it automatically allows you to share that alignment in Civil 3D. So we have an automatic import into Civil 3D. We've been asked to do it into Navisworks, because we talked about coordination here with a bridge deck. In Navisworks, we can coordinate all structures and all assets from different modeling packages. If they also include an IFC alignment reference, now everything can be properly coordinated. So this is an aspiration. And finally, Inventor, exactly the same thing, bridge deck coordination. So I can tell you today that we are definitely working on the Civil 3D export and import at the moment, and we will hopefully do something with Revit in the short term as well. The others will come in time. We can't do everything because this is quite a lot of work, and actually there are the reasons to delay, because obviously they're improving IFC alignment itself anyway, and we want to wait for IFC Rail and IFC Road to see how they manifest themselves. But we are definitely working on this today. Just quickly now, just a couple of examples of, does this actually work? Am I just showing you stuff? So Highways England, they're our National Roads Agency. They've got this aspiration to be the world's leading operator of roads. And BIM is at the heart of their desires. They've got a CAD and data standard, which is their BIM standard. It has many references to BIM within it, and it has full focus on aligning. It says here, PAS 1192 Part 2, so those standards I showed you earlier, they're saying they're going to follow the UK guidance. So the idea is to do it the UK way. They've got some examples. This is one of the first pilot projects. They were looking at linking CAD, treating CAD at the time like GIS. And so they were linking model data to geospatial data, creating databases of information around the project assets, They very much focused on the idea of getting data linkage between the different technologies they were using. So Civil 3D would then link to a database, which would then link to a full geospatial model as well. So they were trying to make sure that everything in the database linked to something in their CAD and their model files and their geospatial files. They have a big program called Smart Motorways, where we're installing lots of signage, electronic signage, new telecommunication systems, and also ensuring people can use the hard shoulder as a way of running extra capacity. They have a BIM program, a whole BIM toolkit they've developed, which is every project on that program is going to use BIM. They're even looking at creating standard libraries of objects. These are approved model objects you can use. So that's highways. This is another quick example of the Environment Agency. This is an example from one of our customers, Mott MacDonald. Was anybody here last year? No? Okay, no, Tom actually came to Russia last year, and he spoke a bit about what they were doing. And so this was a typical detail of a wall for the Environment Agency, and then they've used property set definitions, the things I talked about earlier with Civil 3D, where they've said we've got property sets from the client, so we can apply them at different phases of the project. And using Civil 3D, we can take those property sets, we can create a reference to them, and we can now create those extra definitions that don't exist in Civil 3D that the customer wants. And now we can use that data downstream. So we're taking a civil model into Navisworks, and that same data that the customer's specific information is now available further in the process. And we can even use the Kobe plugin to create that now as a Kobe export, which, if you remember earlier, I showed you the Environment Agency aspiration of we set our requirements, the supply chain delivers models, they aggregate them, and they pump out Kobe. So Tom's example proves that this is now possible. So it's the first time we've been able to get this whole workflow going. And as a company, we are helping customers adopt BIM as well. So just my final example of Autodesk support is really, we've helped companies like Qatar Rail. Qatar Rail is a huge investment in rail, 130 billion Qatari riyals, which is over $30 billion. They've got lots of contracts, 20-year maintenance projects just been awarded for $3 billion. And they've got the metro, it's not rail just, it's metro as well. And we've had a 3-year plan with Autodesk Consulting. And we've developed BIM guidelines, technology platform basis. So Qatar Rail now has a new technology set in the organization. And we're looking at many different aspects. Also looking at UK standards again, and international standards as the basis of how Qatar is going to be done. Sistra, French company doing rail. We've been working with them for a number of years. They're a large company doing lots of typically rail, infrastructure, buildings projects. And it's been a very successful program. They've got their own framework now for doing BIM in the company. Deutsche Bahn, very similarly, we've been working with Deutsche Bahn to deliver BIM on their projects. And they've got the idea of a digital city model for urban integration. So Deutsche Bahn see BIM as heart of their way they're going to deliver infrastructure in the future. And planning as well. UK Network Rail, I've been working with them for 5 years. They're adopting BIM. They do typical kind of small projects, small stations, small platforms. They wanted to get rid of old CAD. They wanted to meet an impossible productivity improvement that they couldn't do in CAD. They wanted to use BIM to get productivity improvement. They had to do what the supply chain was doing. So they were doing this when the supply chain was doing that. And they needed to meet the UK government standards. Instant success on their first projects. They used Revit to do a footbridge. They were able to create a project in half the time they did in their typical CAD projects. And they've just repeated it. So they just said, we're not going to go back. This is a much better way of working. HS2, we've been working with them. They've got their strategy for BIM. We mentioned it earlier. So we've worked with them, and they want to have a strategy where every vendor's solutions can be used. So it's not going to be one solution set. And a report was generated by Autodesk Consulting that showed that you can do BIM on HS2, which is a 15-year project. And the idea is that we'll hopefully use open standards in the future. Today, it's not possible, but it's going to be using both Autodesk, Bentley, and other vendor formats and open standards. And the HS2 is going to invest in open standards development for BIM and to learn how to do BIM on a massive rail project. So they're going to learn and we're going to help them do that. So finally, I think I've tried to quickly go through some of the technical requirements, why we need BIM, what standards are out there, what customers are asking for, and shown how Autodesk is helping deliver those customer requirements. And to me, I'd say BIM is a reality, not just an aspiration. And coming back to this UK model, we talked about the EIR going into the BIM execution plan, going into the master information delivery plan. The things I'd like to say I've shown you is that there are technologies that you can use. And this is the great thing with BIM, is you use different technologies at different times in the project. So you get more and more detail, you add additional information, and you have different tools to use into operation as well. I think you must look at using data management tools, such as Autodesk Vault, during the project. It's very critical to have that because BIM is more complicated to manage. And then you can hand over the data that the clients ask for because we've got the tools to deliver that. And all the things I've shown you are available on that link, biminteroperabilitytools.com. So if you do need to use any of those technologies or you're interested in looking at them, please feel free to download them. Again, they're all for free. And I'm sure you're going to be delighted to know that that is the end of my presentation. Is there time for some questions? Our next speaker is here. Oh, okay. Is our next speaker here? Yeah, okay. But whilst we're waiting, does anybody have a quick question that they would like to have clarified on what I've presented? No, too much information, too quickly. Okay, sorry. I'll get Julia to come here.
A little question about how you save information, all cloud technology, how you save
the project information.
How you save information.
Okay, so the question was, how do we save and share information on projects? Well, I mentioned technologies like Autodesk Vault, or we have cloud tools like BIM 360 Docs, A360. So in our standards that I talked about, there is a process for how you create and how you share information. Do I do it every day? No, well, that is up to you. But on the process we have stages. So in-house, in your office, you can save it constantly. And then when you are ready to share it, you then firstly share and then you publish. And this is all written in our standards. This explains the sequencing. Okay? Yep.
You said what some zip can collaborate from many people in the project. How long Okay. One question, please. Says you say what some zip archive must be prepared for sent to email by collaborate people, and I'm interested how large is this zip archive?
Okay, so the question, I think, relates to the Dutch coins standard, which was a zip file. Yes, that can be very large, but I want to be clear that that is a Dutch, so Holland's special approach, and you share that zip file at the end of the process. So it's not that's not how the project works. The project would use a tool like Autodesk 360 Vault or some other collaboration system, but at the end, the customer says, I want this package, this pack of data, which is prepared in a zip file, and that doesn't have to be sent electronically in the cloud. It can be put on a hard drive, on a DVD, whatever is needed, because it's only done at one or two special phases of a project, if that clears that up.
Can we use now platform, now Vault, for combine this?
Yes, yeah, the question, can I use Vault? Yes, absolutely, Vault could be used because you can expose Vault to the client, and the client could use Vault, and then they wouldn't need to use a zip file. So they could just download the components as they require them. But yes, Vault is an option. For all of this, all these questions on collaboration, please do look at PAS 1192 Part 2, the BIM for Projects standard, because that information, how you do that is described in that. Not the technology, but the process, the steps. Okay, is our next speaker in the room? Let me just check with them. Hold on a second. Sorry. Anastasia? Any other questions? Sorry.
Thank you for your presentation. I have two questions. The first, several years ago was a Euro Roads project. They made a data collaboration standard, and the question is, does Building Smart use this project, Euro Roads, for IFC alignment, IFC roads? And the second,
Okay, so I think the answer is possibly, because the IFC alignment development is an international group. I'm on the infrastructure room that has developed IFC alignment, and there are experts from many European countries, as well as Korea and China involved in that, and Japan. So they may have used that experience to develop IFC alignment. IFC road was developed in Korea, but is being internationalized as we speak now. Okay?
thanks. And the second question, when we can read the special maybe BS or PAS for BIM for infrastructure, not for buildings?
Okay, so my simple answer is the British standard, the stuff that I've shown, is not for buildings. It's for construction sector. Buildings, roads, rail, we are just doing a lot of work to learn how to apply the procedures to infrastructure, because there are some missing technical pieces in doing BIM for infrastructure. It's easier for buildings, is probably the question, answer. It's easier to apply it in buildings, but the standards are not for buildings, therefore the entire construction process, whether it's roads, rail, or buildings. Yeah.